Let's move to the next board where we are going to talk about concept of module. As usual, we will be understanding the concept of module with a nice clean picture. And if you can see here, we have a picture of toolbox, right? What this toolbox is having, this toolbox is having this hammer. You can see that. This is having the plier, the screwdriver, and so many tools, right? And it is always important to use the tools and then place them back into this box. Why? Because whenever you need them in future, you have a reference that basically all the tools are right there in the toolbox. Whatever I need for a particular job, I can just go to this toolbox, just open it, and I will be using the tool, right? As simple as that. Similarly, what we can do is in Python also, we can have a specific file, right? And inside this specific file, we can define maybe functions, maybe we can define the classes, and maybe we can define the variables. We can just define here. Although I'm not saying you cannot run the program, this is the normal standard .py file, which is a Python file. But what I'm saying, you just define few things here, and you have defined three different functions here, right? The name of this file is math.py. The number one program there is, sorry, the number one function is there, the add function, which is taking two parameters and returning the sum of two numbers, a plus b. Similarly, we have another function, which is the subtract or the difference function, which is returning the difference between two numbers. We have multiplication function, which is returning the multiplication of two numbers. We have number one, number two, number three. The important part is in the normal programming, what we see here is in the same file. If I need to add two numbers, what I'm going to do, I'm calling the add function, giving these two arguments 30 and 40, and then basically if I store the result in a result variable and print this result variable, it is going to give me 30 plus 40 is equal to 70. It is as simple as that. We used to do that, right? But what if I do not use this statement? I use this file only to define my functions, to define my classes. Don't you think that it is same as this toolbox? Why? Here in the toolbox, I have plier, I have screwdriver, and I have hammer, right? But here in this file, what I have three functions. Maybe this is my plier. This is a tool, right? To add two numbers. Maybe I have hammer, which is the subtraction function. Maybe I have screwdriver, which is the multiplication function. And all these tools are right there into this file. I'm not using this file as a normal Python file where I'm using this function in the same file. No. What I'm doing is I have defined a file, which is a normal Python file, which is having .py extension, right? And it is just like this toolbox. So if you can compare them, right? Here I have actual tools which are stored inside this box. Whenever I feel to use a tool, I just go towards this box, open this box, and use those tools. Similarly, can I do something in Python also where I can just place all these tools into a particular file? And whenever I want to use these function into my standard program file, can I use them? If yes, then how? And that is the whole soul discussion which we are going to do on board number 2, how we can do that, right? So I have just removed that toolbox, but the right side of the previous board image is right here. I have this file. The file name is math.py. It is just a normal file name, just a normal Python file name, right? Here I have defined three functions, function number 1, function number 2, function number 3. As simple as that, right? And the interesting thing is I have now another file. The name of the file is main.py, or basically you can have any file name. And the important piece is that these two files, which file? Match.py, sorry, not match, sorry for this, math.py and main.py, both are actually inside the same folder. This is the requirement. So basically I have a folder named as class 24 because this is my class 24, and class 24 has two files in it. One is .py, math.py, and the other one is main.py. What I'm doing here is in this main.py, I am importing my underscore math. What is this my underscore math? So I have made a mistake here. So basically this file name is my underscore math.py, right? So when I write this statement and Python interpreter is running this program, suppose main.py, and when it reaches right here, where import.math, right? Import my underscore math. The Python interpreter is going to look into the same folder where I have main.py. I have main.py in the folder number class 24, and inside this class number 24, we have the file with the same name, my underscore math. Although the name of the file here is my underscore math.py, but Python interpreter is intelligent enough to understand that my underscore math and my underscore math.py is exactly the name of the same file. And when I do the import, it literally says that now this file is actually part of my program. And whatever is inside this file, because we have three functions, now these three functions can be used inside this main.py. Don't you think it is the same thing? Whatever we have the toolbox, right, in which we have plier, hammer, and the screwdriver. If I need them, I'm just opening this and using them, right? Right now, I am into the main.py, which is the another Python file. And what I'm doing here is I am actually importing my.math. It means that it is as good as that my toolbox is right here into this program, and try to understand through this my math module, right? So I haven't defined the word. By the way, this math.py, whatever I have, this is known as module in Python. And module means it is just a standard Python file where I have defined maybe functions, maybe classes, maybe variables. In this module, the left-hand side, which you are seeing, math.py, where I have defined only three functions. These are just like tools for me. And this file, which I am importing in my main function, is known as module. It is as simple as that. So whenever I say from now on module, what do you need to understand? This module is just nothing but a Python file which might be defined by somebody, or maybe you. You can create your own module, which you just now did, right? You have created a file. The name of the file is my.math.py. So when somebody says module to you, you immediately, your brain says module is just a Python file, .py file, right? And now you can import this file into any of your program, right? And you have imported it. If you have imported this, then whatever the functions inside this program or this file or this modules are, you can use them in your main program. So you are right now into your main program. And what you are doing is, this is your module name, my underscore math. And whenever you say dot, just try to understand. When we put, in the last class, we created object of the car class, right? Car one. And when we say dot, it is going to give me all the functions wherever they are, whatever the function there are in the car class. Right now, just try to understand. I have this my underscore math, which is the module. If I putting dot here, I can access all the functions which are present in this math.py file, whether it's add, subtract, multiplication, whatever it is, I can call it here with the proper arguments, maybe 30, 40. And then what I'm doing is I'm printing the results. Why? Because actually, when I call this function add, this function is actually returning me sum, right? And that sum is I'm storing in this result one, and I'm just printing this result one. The result is going to be what? 30 plus 40 is 70. It is as simple as that. So what is happening behind the scene? I am again going to explain you. If you have any curious question coming to your mind, just raise your hand. What I'm doing right now here is I'm just saying that math.py and main.py are in the same folder, right? I have defined three tools here, or three functions, 1, 2, 3. If I want to use these three tools in my program, any program, right? I have just imported the complete file here, my underscore math, and I'm calling this file as a module. So I'm importing the module. Once this module is imported in my program, what I'm doing is with this module or with this module object, I am calling the function. I can call any function now because I have this complete file, right? And then I print result 1, and the result is going to be 70, right? So what is happening behind the scene? If I say, Mr. Gomati, I'm coming to you, let me complete this, and thank you so much for asking question. So basically, what is Python interpreter is doing? Just try to understand. When you write my math, Python interpreter is actually checking that whether there is a file called my math name in the same folder or not. It is going to find this, and Python interpreter is going to convert this into the bytecode, because you all know that Python interpreter is actually convert first thing first everything to bytecode and then eventually to the machine code. This bytecode is having a property that it can run on any system. And that is why Python is a platform independent language, right? If you didn't get the last line, that is perfectly fine. But the whole sole point is that Python interpreter find that my math is actually inside the same directory and it's a module. It understands that it's a module. And now with this my math, you can call any function, whatever is defined inside this math.py. It is as good as saying that you have this toolbox, which is having 3 tools. And now you are using the tools inside using this import statement and you are printing the result. It's as simple as that, right? So whenever anyone says that I want to import a particular module, whatever they write after this import keyword, actually this is a module. Or whenever somebody says module, you need to understand it is just a file, right? With py extension where somebody has defined several functions or classes or variables. It is as simple as that. Now, Mr. Gumati, please do ask your question.
No, so I have a small question here. So
Yeah.
if I have multiple or many modules
Mhm.
which I'm defining, okay.
Yeah.
So how come main.py will process?
Yeah. So
I mean,
basically, if you
what?
have
Yeah.
another module, you need to import another module also.
Okay.
As many module as many time you want to install the module inside your program.
In this case, my underscore math has a multiple functions.
Yep.
A plus B, A minus B,
Yep.
A multiplication B, right?
Mm-hmm.
So when you go to the result one into main.py,
Yep.
right? When you are saying add 30 comma 40.
Yep. So basically,
So
the Python interpreter will go and check in the math.py that yes, there is an add function. This 30 and 40 will be passed here, 30 and 40, and it is going to result
okay.
A plus B, which is going to be stored in result 1, and we are printing that, right? Suppose you want to call the subtraction, then my underscore math, as soon as you write dot, it will showcase you all the functions, right? Then you need to choose sub, and then basically you're passing the argument. Now, maybe your worry is that why you are using the same variables A plus B, right? Believe me, basically the functions are different. Whatever you defined in a particular function as a variable is just local to that function. It means that AB is different for this function, AB is different for this function. You can do that. Okay, Mr. Gomti?
Yes, sir, I got it. Yeah, thank you.
Perfect, perfect. Now, let me show you one another way. So what if, suppose, right now, if you import the complete file, my underscore math.py, right? So this is my underscore math.py. If you want to import complete file, then you can have access of all these functions, add, subtract, and multiply. But what if you do not want to use subtraction and multiplication, why to include the complete file, right? If that is the case, you can actually import only few functions which you are interested in, right? And that is the second point, right? Again, math.py file is same, and this is now your module, because module definition is that if some program is importing that into itself, right, then this .py file will become the module. And the only condition is that these two files should be part of the same folder. If they are not, then there is going to be an error, right? So now what I want is I want to import just the multiply function and not these two functions. I'm not interested in adding and subtracting. I am just interested in multiplication. If that is the case, what I'm doing here is just try to understand from my underscore math means from my underscore math dot py file or from my underscore math dot module, right? This is a module. From my underscore math module, just import multiplication function and nothing else, right? Now it is as good as saying that you have these two lines of code right here. And if that is the case, then basically you can directly call this multiplication right here with these two numbers as the argument, and you are storing them into the result 2, and you are printing them. Now the result is going to be 300 because you are multiplying them. It is as simple as that. So if you import a particular function, it is as good as saying that you have just literally picked these two lines of code and place them here. Now you do not need to say my underscore math dot multiplication. Why? Because now you are not importing the complete my math file or my math object. You are just importing the function, and you can use this function. Now this is the time to see the things in action on right here. So here I have a program, right? And basically I have my underscore math.py file. And interestingly, there is nothing to explain here because I have defined an add function here, subtract function here, multiplication function here, and then division function here. So I would like to tell you one thing with respect to division function, that if user has a and b and the b is a positive number, then basically it is returning a division by b. That is perfectly fine. But what if user has given b equal to 0, right? So in the exception handling class or error handling class, we mentioned that there are some inbuilt exception, and the division by 0 was such inbuilt exception. But in the same class, I mentioned that you can have your own exception. You can raise your own exception. So basically, that is what I'm doing here. That if b equal to 0 means the numerator a divided b, if b is 0, then basically we cannot define this division. And I'm saying raise an error, division by 0 is not allowed. You can do that. That is perfectly fine, right? So just wanted to just give it a look whenever you have something, right? So right now I have defined this my underscore math dot file, and I have this file also main1.py, right? And the interesting thing is that main1 file and my underscore math file, though both are in same folder, and the folder name is class 24 because today's class is 24. In this folder you can see I have main.py and I have my.math, right? So it is very interesting to see now what is there in the main1.py file, and let's see that, right? So first thing first, what I'm doing here is, let me change everything to the comment first because I want to showcase you step by step. Here you go. So these three is the lines of code, whatever I'm going to execute now, right? The first line is this one, import my underscore math. What I'm doing from here is, you all know now that Python interpreter is going to check that here is my first line of code which says import my underscore math. So Python interpreter is going to see that whether my underscore math file is there or not, and it is going to find it for sure. It is right there, right? You can see that my underscore math file is right there in the same folder, so there is no problem. So it means that now my underscore math file is part of this program, right? And what I'm doing here is I am just writing my underscore math, and I will showcase you this thing, right? As soon as I write my underscore math, which is my module name, and as soon as I write add, just try to understand that it is showcasing me all these functions: add, division, multiplication, subtraction, which was there, right? In my math.py file. These are there, right? And I can see here. So what I'll do is I am calling the add function, and then I am passing the two arguments, say 30 or say 40 comma 30. It's as simple as that. And I'm printing the results, right? Because my math function was returning me the sum of 40 plus 30, which I'm going to store in result one, and I'm going to print it. If I do the print, sure enough, it is giving me 70, right? But suppose if I write here math 1, 2, now it is giving me error, right? And it is saying my math 12 is not accessed by, right? And why? Because my math 1, 2 is not a file there, right? Inside this same folder, which is the name of the folder is class 24, right? And if there is no .py file with the name my underscore math 1, 2, it is going to give me the error. And that is why I'm going to delete this, right? So you should understand by now that my underscore math is just a file. And if I'm importing that py file into another file, that becomes module, right? So now let's see the another way. I am making everything now comment. And now let's see what is going to happen if I import only multiplication, right, from this module, because this is having so many functions, sorry, so 4 functions it is having. And now let's see what is going to happen, right? So interesting. Now I would say multiply, and I will say 30 and say 40. What is going on now? Now there is a slight change. What is the change here? I am from my math module, I am just importing multiplying function, right? And I am now it is as good as the multiply function is right here. And that is why I do not need to say my underscore math dot something, right? I am just saying multiply 30, 40, and I'm storing the result here. So basically the result is going to be 1200. It is as simple as that. Let's see that. Let's try to run this. And sure enough, 1200 is the result. Now, what if I want to import another function, which is a division? So what you can do is you can just write comma and you can write division, right? And now basically it is importing division as well as multiplication. Let's use this. I'm uncommenting this. Maybe I can comment or uncomment, that's fine. So here the result is going to be 1200 and here the result is going to be 5 because 50 divided by 10 is 5. So let's have a look at that. And sure enough. So basically whatever way you prefer, just use it. Mr. Supreet, you raised your hand. If you have any doubt, please do ask your question. Do not hesitate at all.
No, Vishnu, it was by mistake. I clicked by mistake.
Perfect.
Vishnu, Prashant here.
Prashantji, please do
Yeah,
ask.
here,
Mhm.
yeah, here we are defining 30 and 40. I should ask us to enter the values with. How can we do that? Let's say I want to enter 10 and 40.
Haha.
So
So
can we do that?
yeah, you can change the value
Yeah.
here.
I don't want to change here.
Okay.
When you execute the
Basically,
program, right?
then
Ask.
basically you can define the program here, that input program, right?
Okay.
You can say
Mhm.
here input whatever, maybe the num1, right? And instead of asking the values, basically you can say because now you are not interested in taking the value, right?
Yes.
And you can say here, or basically if you do not want to touch this function, believe me, there is another way. Just wait a minute. So what I can do here in main program, right? Instead of passing it here, what I can do is num1, right? I can do integer, and or basically you can convert into integer later. You can say enter first number, okay? And then you can say control C, control V, enter second number. And this should be num2. So here, Mr. Prakash, you can pass what? Num1 and num2. Is it making any sense?
Yes, Vishnu.
Right? Now, basically, it can ask these two numbers. So if I run this program, so it's up to you where you want to define. And you want to change that, enter first number, maybe whatever, 12 and 34. Okay, this is very, very interesting. So it is saying return A star B Okay, so basically, see, generally it is going to take this value, right? So I think I need to change it to
Yeah.
integer, right?
Yeah. Integer. Yeah.
Yeah, because it is saying there that you are sending the integers and you are trying to do this operation, right? So does it make sense now? Let's
Yes.
see this. Let's try to run this again. So here you go. First number maybe say 10, second number say 20, and sure enough, now we are getting it. Okay, but it's a good question. So let's talk about the next board where we will try to understand the concept of packages. Okay. Now, again, the concept is going to be same. What I'm doing here is now instead of one toolbox, what I'm having is another toolbox, right? This is the smaller one. This is maybe again the smaller one. Then we have the bigger toolbox. And then here also. Previously in a particular toolbox, what we have several tools. Similarly, in the particular py file, we have several functions. These are tool 1, tool 2, tool 3, right? What if we have so many .py file, or if we have so many toolboxes? Maybe you are working on a project where more than 100 people are working with you, and then everybody is writing their own module, which is a py file, and in no times you can see that in a particular folder you are having more than 1000 files. If that is the case, inside one folder you have more than 1000 .py file, which are just like modules. So one thing to think here is that whenever I say module from now on, you are going to understand it's just nothing but it's just a py file which can be incorporated or imported in another or other py files, right? Then this will become the module. But now the problem is that in a particular folder we have more than 1000 .py file or modules. If that is the case, how we are going to manage them? This is a management problem, right? So you have found out the solution that the modules which looks very similar, what I'm going to do is I'm going to place them into a particular folder. So out of 1000 file, I found 400 files which are kind of similar. So I will be putting them here, 400 files, and in another folder I will be putting 300 file, and in another folder I will be putting 300 files. So this way basically I can arrange these modules, right, into particular folder. And this is what you also do. When you need to arrange so many files, you fit them into a particular folder and you name that particular folder so that you can identify those files, right? Maybe suppose you have a lot of pictures, maybe 5000 pictures you have, right? Those pictures include your pictures from trip 1, maybe to Australia, trip 2, maybe to northern part of India, and there are some picture from your marriage, right? Maybe birthday party of your kid, and so on. There are 5000 pics. What you're going to do, you will be arranging them into different folders so that all the trip 1 files, Australia trip files, or the pictures are going to be in the Australia folder or the trip 1 folder, marriage folder, birthday parties folder. Why are you doing this? Because you want to arrange them. Similarly, if you have so many modules, you need to arrange them, right? What I'm doing here is, suppose I have 3 different .py file. One is math.py file, which is having functions specific to mathematics like addition, subtraction, and so on. I have volume.py file, which is calculating the volume of different shapes like cube, sphere, and so on. I have area.py file, which is calculating the area of different uh, figure like rectangle or circle. But at the end of the day, you can figure out the similarity between all these things. These are mathematical modules, you can say. So what you are doing is you are creating a folder with the name mathematics, and you are just putting all the files, mathematics related files or mathematics related modules into this particular folder. Similarly, suppose I have a folder which says operating system, right? Maybe operating system has a particular file which is dealing with the memory operation, process operation, CPU operation. We have 3 different files, and we all know that these files are related, and we would like to put them in operating system folder. But what is the point? The point here is just the arrangement. Within no time, you can have so many modules. Whatever the module which are similar looking, you put them in a folder. And by the way, now this folder is known as your package. So what is a package? Package contains multiple modules which are looking similar or basically mostly similar. This is my package mathematics package. This is my operating system package. It is as simple as that. So if somebody says module, you are going to understand it just a .py file. If somebody say package, you are going to understand it is just a folder containing many py files. As simple as that, right? So is this the only condition of creating packages? It is, right? But there is one thing which needs to be there whenever you come up with the module, right? Sorry, package. And that is the whole soul discussion point of the next board, where we are going to talk about this thing, right? The package in detail. Suppose I have a folder, class 24, today's class is class 24, and inside this class, I have created a folder, and this folder name is loop. Inside this folder, now I have star.py file, and you all know if I'm defining some functions here, this is just my module, right? It could be there can be any number of files here, .py file, but just try to understand the structure. I have class 24 folder, which is my main folder. Inside this folder, I have created a loop folder. The name of this folder is loop, and inside this, I have a file star.py, which is doing something. Actually, this is printing just the star. In first row, it is printing 1 star. In the second row, it is printing 2 star, third row 3 star, fourth row 4 star, and fifth row 5 star. What is the logic? We can understand it later. But just try to understand it's just a file. It is just a function. And we all know that if we have put this star.py file inside this folder, then this folder will become my package. And maybe there can be any number of .py file inside it. But here, wait a minute. How come Python interpreter comes to know that if you place a .py file or many .py file inside a folder, then this becomes package? How come Python interface knows about it? So there is only one condition. If you want to let Python interpreter knows that this loop is actually the package, you just need to create one file without writing anything in this file. What you can do is you can just name this file as init.py. The name of this file is underscore init underscore.py. If you have created a file with this name in a particular folder, Python interpreter is going to take that folder as a package, and that is the whole soul condition. That is it. So inside this loop folder, if you have defined underscore init underscore.py file, the loop folder is going to be package for you. What is the name of this package? The name of this package is loop. What is the module inside this package? The module inside this package is star.py. It is as simple as that. Now I have another file, main.3py, which is part of the same folder. And inside this folder, what I'm doing is I'm importing loop.star. What is the meaning? Loop.star. Loop is actually my package, and inside this package I have star.py, which is my module. So module, so first of all package, then dot module, and I'm importing it. It is as good as saying that now star.py is part of my program, and now what I can do is loop.star underscore design. What is star underscore design? This is the function I have defined here. So now inside the star.py, I have this function which I can call. It is as good as calling a module, but because now this module is part of this package, I need to write the package name first and then module. It is as simple as that. Another way is that I just need to install or import only the function star design. What I can do is from loop.star. What is the meaning of loop.star? This is my package. This is my module. From this package and module, just import this function, and that is it. If you do that, you can call the function straight away. It's as simple as that. I'm again repeating, this is very, very simple, right? If you want to make a particular folder as a package, just create a file inside that with the name init.py. Once you do that, whatever the number of modules you have inside this folder, Python interpreter is going to say that this folder is actually your package. And now you can import this package into any file with this folder name. That is it, loop, and then basically whatever the number of modules you want to call from it. Maybe this folder can contain n number of modules. You need to import them, whatever you want to use. But the whole sole point is why we have done all these tricks. We had so many .py file means modules. If you want to arrange them, then arrange them into the different folders, and these folders will become the packages if you define, if you have init file, init.py file in it. As simple as that. Now, it is good time to test this in our Visual Studio Code, right? So what I'm doing here is I have, just wait a minute, guys. I would like to tell you that what I have here. So this is my class 24 folder here. Inside this class 24 folder, I have this loop, and inside this I have two files. One is init.py and the other is star.py. So how the structure is looking, class 24, this is my folder, right? Inside this folder, I have another folder, which is loop. The name of this folder is loop. And inside this folder, I have two files. One file name is __init__.py, and the second one name is star.py. What is happening? And in this file, basically, I have defined a function, right? So if inside this folder, if you have this file, this folder will become, what it is going to become? This will become package. As simple as that. And now in the same folder, I have another file, and the file name is main.3 or 2, right? This file. Now what I can do is inside this, I can say loop.star.py. I can import. As simple as that. Why? Because now Python interpreter, because I have this file defined, Python interpreter is going to say that this is actually your package. Now just try to understand that in this main.3 file, what I have, I am importing loop.star, right? And loop.star dot, if I write here just dot, you can see it is showcasing me the function inside star, right? Let's see that. What is the function inside this star? Let me open this star file here. You can see here, and the function is very, very simple. This file contains only one function, define star. What is it is doing? It is just printing star, and this is very, very important to understand the logic of this program. I leave it for you. But at the end of the day, this program, what it is doing, this is actually printing first line 1 star, second line 2 star, third line 3 star, until 5 lines. If you don't believe, let me showcase you this, right? Let me remove this first thing first. And if I simply say, if I simply call star.design and here this function, and if I run this function, try to think, right? Try to understand the logic also. So what I'm doing here is the main3.py is I am just importing loop.star. What is loop, guys? Loop is actually this folder right here, which is inside class 24. And because loop is now a package, why it is a package? Because I have defined this init.py, and I'm calling this thing, which is star module inside my loop package. And if I want to call the star.design function, what I need to call loop.star.star.design. And if I run this program, believe me, it is going to print these 5 lines of stars. And sure enough, So basically this is the first way. If I make this comment and make them uncomment, right? What is going to happen? Now I am from loop.star, I am just importing this function, and that is why I can call this function again. It is up to you which mode you want to define, which mode you want to import, whether you want to import a specific function or the complete module. It is up to you, but the result is going to be the same. Just try to understand, right? Here, not same. Here, basically, you are just importing one function. Here, you are importing the total module, and here you go. If you do that, sure enough. Now, I think somebody has raised his hand, but now I cannot see any hand raised. So if you have any doubt, any question, please do ask your question, and this is the right time to ask. Anybody? Okay, at least tell me that whether you are able to.
Vishnu,
Yeah, please go ahead.
just wanted to know if you have defined anything under the file name init.py.
Nothing. So if you see here, init.py is having nothing. Basically, this file is just a way to let Python interpreter know that now this folder is actually package. Which folder? In whatever folder, if you want to define this init.py. Okay. Is it making any sense?
So
Yeah, go ahead.
So if you want to create a package, then underscore initiate .py, it is a mandatory to create.
Yes. Actually, this is the only way through which Python interpreter understand that this folder is not now a normal folder which is having .py file, but this folder is actually the module. Okay. Perfect. So now.
So, and one more question. So if I click the .py, go to the folder and the file and the main3.py, if I double click, will it run, or we need a visual editor file?
I didn't get that. Visual editor file?
No, it's a general question. No, it's a general question actually. So we have a Python file, right? Main3.py, right? I've just stored in one of the file, one of the folder. Okay, in the D drive and any folder, and under the folder, this is the file.
Yep.
So I'm going to that file. If I double click main3.py, will it run automatically, or like exe file, right?
Basically, if you have converted that into the exe file, it should run automatically. We can do that. We can do.
Okay.
But right now it's a py file, so you need to run it with a Python interpreter.
Okay. Yeah, I got it.
Yeah, perfect. So now, if we go ahead and see, I would like to tell you another interesting thing, and this is the dir function here, right? So as you all know that we have one math module, right? So we have our class 24 folder, and inside that we have my_math.py file, which is having 4 functions, you all know, right? And then along with that, I have a main file, maybe main1.py, right? So what is happening here is, or the directory file, whatever, right? Actually, sometimes you want to know, for example, right now, my_math function is defined by you. So you know that there are 4 functions in this module, right? But what if somebody else has defined this module for you, and you want to know what are the functions there inside this module? What are the classes or the variables there, right? What if you want to know? It's very, very easy. What you can do is you just need to write the name of your module, whatever the module it is, and just say dir and then print it. So this dir is the function which takes argument. What is the argument? Module is the argument, module name. And whatever you give, then basically it is going to give you what are the different functions, classes, and variables are there. Let's see that. It is very, very interesting. Okay. So if I open mydir.py and I'm saying my math, inside my math, you all know that we are having these 4 functions, right? And if I open my dir, then what I'm printing here is, let me make first of all this line as comment. I'm just printing what are the different functions inside the dir, sorry, inside this my math. Let's see. So Let me run it. And sure enough, if you can see here that basically we have add, division, multiplication, subtraction. So basically it is returning the list, and this list contains all the functions I have. But this also contains other things, other variables also. So these names, basically name and package and other things, are basically in the file. These are just the other variables which is defined by the Python. So I have created this my underscore math. I haven't created all these variables. Python has created on behalf of me. But let's find that what these are. So if I uncomment this line and I am doing the my math and then dot this file, this is the variable. So it is going to give me the file path where exactly this my math module is. If I print it, and sure enough, it is showcasing me that basically my underscore math.file is in class 24 folder, which is part of codebase folder, which is part of Vishnu folder inside C directory, right? So if you are not finding this much useful, but this is very, very interesting and useful because it is letting you know, it is actually letting you know that you have this my math, my underscore math, right? Which is the name of module. If you want to know what are the different function, classes, variables inside this, you just can print using this dir. It is as simple as that. Very, very easy. Okay. Having said that, what I would like to tell you, I would need another 10 minutes of your, or maybe 5 minutes, because now we are into the position of understanding the program, the complete program, which I gave you in the last class. Before that, Mr. Rahul, what is your question?
Vishnu, just one confusion there. When you said like to run a program, to access the module, the program and the module has to be in the same directory, right?
Yep.
So when we are creating the package, so all the module is there, the package is there. So all the file which I am running the program, that also becomes a part of that package.
Yeah. So okay, I'll let you know that structure. Okay. So basically, where everything should be there. So we have this class 24. This is the root folder, whatever you can say. Okay. Now I have something, my main program here, where I will be calling all the packages and module, right? So if I have a folder, I have several folders, suppose, and all these folders are having init.py, and then many.py files. So basically, whenever I say that, suppose this is my P1 package number 1, if I say import P1, and inside this I am importing file 1 py, right? Dot file 1 py. So basically, Python interpreter is going to check here all these directories inside class 24. Is it making sense, Mr. Rahul?
Yes.
Perfect.